Hey everyone, welcome back for another episode of Code Club here on the Riffimonas YouTube channel. I'm so glad to have you joining in. In today's episode, I am going to be recreating this figure with you all and using R and ggplot2 and other tools from the tidyverse. This is a figure that was published by the New York Times last month showing the redistricting of congressional districts in the state of Texas. So this was a big controversy over the summer in the United States. I don't think this story of redistricting is quite over here in the United States. It sounds like other states are going to be redistricting to try to increase the representation of the dominant party in their state in the coming months. All right. So thank you, Mike, for joining in. As you join in, feel free to introduce yourself and tell us where you're joining us from. And I am very happy to answer any questions or kind of take suggestions as we go along. If you say, Pat, why didn't you do it this way? I'll do my best to kind of go ahead and try to do it that way, okay? And so before we get going too far, I just want to remind you that I do have a mailing list. If you go to riffimonas.org, and I'll go ahead and paste that in here into the chat. And if you give me your email address, then about every week I will then send out a newsletter. And the newsletter you can also find on the website, which I'll go ahead and paste here into the chat. And you will get kind of a discussion of a data visualization like this one that we're going to talk about today that I found out in the wild in like the scientific literature, in my reading of the media, or of things that people send to me, right? And so this version is a little bit different from the version that we're going to go through today. But, you know, the discussion that follows more or less kind of gives you a sense of what I'm doing. Also in these newsletters, I tell you about upcoming workshops that I'm holding or video recordings of workshops that you can purchase from me as well, okay? So what is this data? What is this plot about, right? So again, it's from the Texas redistricting here in the United States. We have, I think, kind of weird process for figuring out representation within each state that goes to the federal Congress, right? I say ours is weird, but I suspect yours is probably weird too. So I will try to briefly describe it and why this is a controversy, because the backstory doesn't really matter for making the plot, but it is relevant for perhaps understanding what's going on in the plot, okay? And so in the United States, every 10 years, it's mandated in the Constitution that we have a census of the number of people living in each state, right? And that number is used for a lot of things, but most importantly, for figuring out how many representatives go to the House of Representatives in the US Congress. Every state gets 2 senators, right? That's kind of the upper house of the legislature. But Texas has 38 representatives. It's a rather big state. It's a big geographic state, but also has a large population, okay? And so, you know, I live in Michigan. And so Michigan, we often show people as our hand. I live down here, right? And so there's actually another part to Michigan, which is the Upper Peninsula, which is a beautiful place to go. We actually got the Upper Peninsula with a trade for Ohio. We got the Upper Peninsula. They got Toledo. I think we won. Anyway, so if you look at like the state, you might think about like kind of dividing it by equal geographic area. But we know that there are cities, right, which have more people, and there are rural areas that have fewer people. And so dividing it equally by geography wouldn't really work. It wouldn't give equal representation, which is what Congress is meant to do, right? And so, but as we kind of think about urban areas and rural areas, at least currently in the United States, the rural areas tend to be dominated by the Republican Party and urban areas by the Democratic Party, okay? And so there's ways to draw the lines to create these different districts to alter the makeup of representation, right? And so that is what is at stake in this debate, right? So as this was published, the current districts was kind of the beginning of the summer. The proposed districts have actually now been signed into law in Texas. And the point was that the Republicans in the state legislature recreated the districts so that the Democrats would lose 3 seats in Congress in the next election if we use kind of the vote margin for Trump over Harris in the last presidential election as a barometer of what's going on. And so this process of redrawing lines and making lines and polygons that are pretty funky shaped is called gerrymandering, okay? And so the Democrats in the Texas State House fled the state, because if they were not in the state, then they couldn't be compelled to come back to the State House and vote, right? And so if there weren't enough Democrats, if there weren't enough people in the state legislature, then they didn't have a quorum, they couldn't vote on these things. And the Republicans did all sorts of things, not necessarily good things. I don't know that Democrats, if they were in power, would have been any better with what they'd proposed, but anyway, it was a big showdown, and it was a bit of controversy, okay? So again, this is the plot that we're going to make. And so one of the challenges is, how do we get the data to make this plot? So let's start there, right? And so I've got an article in here that I'll share with you that's from Wikipedia about gerrymandering if you want to learn more about it. And I realized I forgot to send that earlier link. I'll go ahead and paste this in as well. And one of the other things to know about gerrymandering is that it has a real, I would say negative, a negative connotation in the United States historically, not just because of like political party representation, but also because of racial representation. That that urban areas tend to have more minority populations, right? And so if you can kind of dilute their voice in Congress, then they are not as well represented. And this is a big historical problem, obviously, in the United States. And so I think states are feeling emboldened to gerrymander and to, again, effectively dilute the voice of minorities in cities because of the current administration and kind of the changes in the makeup of the courts. So one other thing that we'll go into now is this article that I have from the New York Times, which will hopefully pop up here. That shows, this is a free version of the article. Again, I trust that this is legit and somewhat legal, that archive.is shows up these articles. And so this is an article about the redistricting process in Texas, right? So this is what things looked like at the beginning of the process. This is what things looked like at the end of the process, right? And you might say, well, I don't really notice any differences, but you might perhaps see like this pink wedge and this pink wedge are pink, right? They're not very bright red, right? Whereas in the new version, they are more strongly, more likely to go towards Republicans in the next election. And also there's a district that went between Austin and San Antonio that kind of gets clipped with the O in San Antonio. That's now 2 smaller districts, right? And so there's all this like machinations that go on, right? Great. Thanks for joining Robert and Syed and Georgie from the country of Georgia. Wonderful. And Rents, great to have you from the Netherlands. We're getting going here. And so they kind of go through all this, right? And so if you go further down, you can kind of see whatever. If you're into maps and geeking out about politics, how things have changed and how they're modifying things, right? So the question then is, how do we get the data, right? And unfortunately, even on the live New York Times version, these maps are not interactive. It's not totally clear how to get those data, right? So thinking about Wikipedia, I know that they have articles about all of the presidential elections. And actually, you can tell I've already been here, but that if we go to the article, 2024 US presidential election in Texas, I will go ahead and plop that into the chat. And kind of the section that I tagged was showing it by congressional district. So there's 38 congressional districts. And this table, at least, has the percent that went for Trump, the percent that went from Harris, and then who their representative is, right? So this is a piece of data that we can use to get the values for the current districts. So if we come back down here, we can use the data from Wikipedia to make this upper plot. The question then is for the proposed districts, right? And so I wasn't really sure how to go about doing that. Some of the other versions of this plot that I have seen here and in other news sites have given an attribution to some organization within Texas. I'm not seeing that on here, but what I did, or what I'm going to show you I did, is I'm going to go ahead and I'll go ahead and highlight or take a picture of this proposed districts. I'm then going to go to images.google.com, and I lost my screenshot of that. And so if I come back to there, I can go ahead and plop in my screenshot, right? And this then shows me Google Images searches for that, right? And there's a link here for redistricting in Texas. I don't know. This is the Texas Tribune. And this, lo and behold, has the map, right? And so then this is the proposed map. And you can see as I hover over each of the districts that I get a pop-up, right? And this source tells us that this comes from the Texas Legislative Council. I went to their website, but I wasn't able to find anything. And so I'm going to do one of my favorite tricks, which is to view the frame source, right? Or you could do view page source or view frame source. This most likely is being created by a tool called Data Wrapper that a lot of news organizations use to put visuals inside of their articles. So we'll go ahead and do view frame source. That didn't work the way I'd hoped it would, but I see a URL in here, which is that. And let's see, let's go ahead and copy that. I'll paste that into here. It's got this and format JSON, which if I do that, I get the interactive map all on its own, right? And I'll go ahead and throw that into the chat if you're interested. And so one of the things that I have learned about Data Wrapper over the years, or over the year, is that if I take their URL, the Data Wrapper URL, and at the end I put data.csv, that will download the data for the visual, right? And so you can just see that it downloaded that for me. And so if I go to my downloads directory, you'll see I have this data file. And actually, as I think about it, maybe I won't download it, but I'll open it directly in R, right? So I'll go ahead and copy that URL, come to RStudio, where I've got a script called txgerrymandering.r. I've got my library tidyverse call already in there. And if I do read_CSV and then put in the URL with data.csv, let me come back to my console, load my tidyverse, and then run my read CSV, I then get the file, right? The file that's being used to generate the map of Texas with the proposed or the new congressional districts, right? And so that way then we can do this. Sorrenta's saying that there is an R package to get the API from Data Wrapper. So data W wrapper. It's funny. I'll have to check that out because Data Wrapper comes up a lot as we are trying to recreate plots from news organizations. Okay, so we have the new data, right? And so we also want to get the old. Okay, and so I'm going to hold off on defining it as old. So again, the old, the previous, maybe I'll call it previous, we're going to get from Wikipedia. And so let me come back here, and I've got this. This will be my URL, and I think I want the URL, not the section URL. And so let's come back into here, and that's a long URL that I'll put in quotes. And there is a package called rvest, which I'm not sure if it's actually part of the tidyverse, but it's pretty widely used. It's developed by I think originally Hadley Wickham, but I think certainly folks at RStudio, and it's a pretty legit package is my point, okay? And so I can do read underscore HTML on that URL. And then that gets me a bunch of HTML like gobbledygook, right? And so one of the nice tools in RVest is to get the HTML tables. So we do HTML underscore table. And then this will create a list that contains all of the tables within that HTML, right? And so how many tables are there? There's like 48 tables, right? And I don't know what they all are. Some of them probably aren't like tables like we think. But let me scroll back up to the top and maybe we can find the first one. And that will maybe help us to orient ourselves to what we're looking at. And so maybe we'll look, let's look at the third one because that's a little bit easier to see. Again, if we come back to here, I believe that nominee party home state, let's see, nominee party home state, right? So this here is an HTML table that is showing up here as element 3 of our list. And again, there are 48 tables in here. So I need to go through here and find the table that corresponds to the congressional districts. And lo and behold, I think this is it, right? Where we have the district and it tells us that there's actually 42 rows, which is weird, and then 4 columns. So the district, Trump, Harris, representative, right? So we're gonna wanna run HTML table, and then I can use a function called pluck, which works very nicely with lists in a pipeline framework. So I can do pluck 44. This then brings me a tibble of the data that we saw, way down, this is by county, right here, right? So this is this table within Tibble. And so I think one of the reasons that we have 42 instead of 38 is that there are a couple of districts that had multiple representatives over the past few years, okay? And so they have, we don't care necessarily about the representative name. All we care about is the district number and the percentage for either candidate, okay? So we have our data. Now, though, we need to get it into format that we can play with nicely. So I'm going to start by working with the previous data, right? So we'll call this previous, and this gets us our table. Now, like I said, I want a column for the district, and I want the difference between Trump and Harris. I don't care about the representative. I don't really even care about Trump or Harris on their own. So to do that, I'm going to need to turn district into a number. I'm also gonna have to turn Trump and Harris into numbers. And to do that, I'm gonna have to do some string manipulation, okay? So to manipulate a column, we'll do mutate, and I'll do district. You know what? Before I do that, I'm gonna go ahead and turn everything to lowercase. So we'll do rename all to lower. And so rename all will run the to lower function on all of my column headings, like we have here. And now I don't have to worry about capitalization. So I'll say mutate district equals, and then we'll do str remove on district. And I'm gonna remove 2 non-digit characters. So backslash lowercase d will match a digit, backslash uppercase d will match anything but a digit, right? So now if we run that, it's upset with me because I forgot the pipe here. All right, now what we see is that the ST, the ND, the RD, the TH for first, second, third, fourth have been removed, right? And I do want to turn this into a numeric, right? So I can then say as.numeric. And so now what we get is district as a double, okay? Cool. So now we're gonna do the same type of thing for Trump and Harris. And you know what? I'm gonna copy this down for Trump And then we're going to want to run that string remove on trump. And we're going to want to remove the percent sign. And so now when we run this, trump has become a double. And we can do the same thing for Harris. All right. Oh, I think I didn't quite copy Harris. All right, there we go. And so now we have district trump Harris as doubles. I don't really care about representative, so we'll hang on for now. And then let's say difference equals trump minus Harris. And this then gets us a column with the difference, right? I am going to then go ahead and run select on the district and the difference. And this then will get us our data for the district and the difference, right? And what I'm thinking about is that we're going to have the previous redistricting program, right? And then we're going to have the new version, right? And what I'll ultimately do, I think, is use something like bind rows to combine those two data frames together. But what I'd probably like to do is maybe have a column to indicate if it was the previous or the new. I'll hold on to that for right now, though. So let's go ahead and call this previous. I've already got the name there stored. And for the time being, I'm going to do the same type of thing with read CSV to then do the same type of manipulation. These values are already in doubles, right? They're numerics. So this should be a little bit easier to modify. But again, what I'm going for is a data frame that's got the district and the difference, right? So let's go ahead and do rename all again, and we'll do to lower. And of course, that gets us lowercase district. So we've got that. And then we're going to do a mutate to get difference. And that then will be trump percent minus Harris percent. And wouldn't you know it, but that went off the side. Actually, there is a margin of victory column already in here. Maybe I'll use that instead. Let me back up here. All right. I didn't see that because that wasn't in like the number of columns that were being shown. So why don't I do this instead? So we'll do select district equals uppercase district. And so what this will do is this will rename district to be lowercase for me, right? And it will also return a data frame that's got the district column. And then I also want margin victory. That hyphen is going to cause problems. So that needs to be stored in quotes, right? And I'll say difference equals margin victory. And so now what we see is we have district and difference, right? Cool. We'll bring this all together, load that as new, and we're in good shape. And we'll go ahead then and do bind underscore rows on previous and new. And what we'll see is not exactly what we want. As I mentioned, we now have 80 rows and 2 columns. This reminds me that I forgot to remove those duplicate rows from the Wikipedia data. But the other thing I was noticing, of course, I mentioned a little bit earlier, is I don't know what data is from which districting process, right? So let's come back up here first to look at previous. And so previous, like we said, had 42 rows. If I take previous and then print n equals inf, then let's see, I think 18, right? So 18 got duplicated, right? And so what I could run in here then is distinct. And so distinct will return the unique rows from the data frame. And so now if I look at previous, I've got 38 rows. That is good. And I could create a column in previous and new to indicate that it's from previous and new. But I'm wondering if bind rows might have a way to do that for me. And so let's look at the help for bind rows. So there's a .id, the name of an optional identifier column provided as a string to create an output column that identifies each output. The column will use names if available, otherwise it will use positions. Cool, so we'll do that. So we'll go ahead and do .id equals districting. And I think this needs to be a string, but we'll see. Yep, it needs to be a string. And so what we see then is that we get districting 1. And if I look at the tail of this, I bet I'll get 2, right? But I would like to use the actual name. So let's go ahead and do previous equals previous, new equals new. And so now what we get is the new and the previous listed as the type of districting, right? And then we've also got the district and the difference, and I still have this tail on here, which is why I think it's looking a little bit funny. But there we go, right? Cool. So now we have our data, our redistricting data, to go ahead and make our beeswarm plot, okay? Awesome. Before I do that, this red X is reminding me that I haven't populated the width and the height. And actually, before I started recording this, someone posted a comment that I noticed saying, why do things look so weird when I make the plots, or when they make the plots, using the plots window down here? And so they were thinking they were doing something wrong. And you'll notice that when I make these videos, and I'm realizing I'm not showing my full screen, sorry, that I don't typically comment on the plot that's over here in the plotting window, right? I always run ggsave to create a PNG, and then I open up the PNG file. And that's because the size of like your fonts and your thickness of your lines and all those types of things depend, the way they appear depends on the aspect ratio and size of your figure, right? And so, I might move this bar around or whatever to change the size of this plotting window, and that's then going to change the way things look. But and that's certainly going to vary perhaps between you and me, or between when I'm doing this today or when I'm doing this in a week. But what won't change is if I run ggsave and give the actual width and the height. So let me show you how I do this. So I'm in my TX gerrymandering directory, and I've got the original file here. And again, this will work on a Mac. Not totally sure how to do it on Windows, but there's ways to do this type of thing on Windows. You can run file on TX gerrymandering original.png, and I get the aspect ratio, 1892 by 1548. And I'll put that there. And so what I want is I want something that's 6 inches wide, and then I want to know how high, right? So this first set of question marks then is going to be 6. And so if I do 6 divided by 1892 times 1548, that then will tell me that it should be 4.91, right, as the height. And so that's how I go about picking the dimensions for these figures, at least where I'm recreating them. I'm a scientist, and so oftentimes when we go to publish our figures in a paper, the journal will tell me, how wide can a figure be? And so I will plug that number in here for the width or maximum width that I can have, or the minimum width that I can have, and then scale the height accordingly to get something that looks good. And again, this is going to be far more reproducible than depending on this plots window. I really don't like the plots window, except for doing some quick things or kind of diagnostics. So great, we have that. And now we are ready to start plotting our data. And so we'll go ahead and pipe this to ggplot. And I forgot a G, ggplot. And so our AES, our aesthetics, on the x-axis, I'm going to put the difference. On the y-axis, I'm not going to put anything. I guess we could do like districting. Let's start there. We'll do districting. And we also want a color that is going to be, I'll say, what? Let's do winner. And I need to create that column, right? So if I do mutate winner equals if else, so if the absolute value of districting, or if I just say, let's say districting is greater than 0, then that's going to be Trump. Otherwise, it's going to be Harris, right? And I'm wondering if I've got the right parentheses. That looks good. I always look at the height because that gives the image is running over the page width. Oh, flip that, yeah. So let's go ahead and switch that. And then for now, I'm going to go ahead and do geom jitter. And we've got our GG save. So let's go ahead and look at what we get here. And I need to open up that directory. Oh, where do I have things? Okay, there's what I've got. Okay, so this then has me having winner as Trump. I think I did something wrong because everything's the same color. So mutate if else districting. Oh, districting greater than 0. I need the coffee. Difference is greater than 0. Now what we see is that we've got previous and new, and that we've got things colored by whether it's for Harris or for Trump, right? Cool. So this is how I might normally make this type of plot, because I'm a big fan of geom jitter. But if I shrink this down a bit to kind of the same window size as theirs, make sure I got that right. Oh, there we go. You'll notice a couple things that are obviously different between mine and theirs, but thinking ahead about how the data are represented. So first of all, in theirs, they've basically got 2 panels within the same figure, right? And so I can do that in R using like facet wrap or facet grid, right? And so in that case then, I would make like the y-axis value 1, because that's going to be the y position. It's going to be 1 for everything, right? Another thing that I notice about theirs is that when the values are greater than 20, so greater than plus 20 or less than minus 20, you have the solid red and blue colors, right? But if it's between 10 and 20, either positive or negative, there's a lighter shade of red and blue. And if it's within negative 10 and 10, it's still a lighter shade, right? One other thing I notice is that the limit is at 40, right? Whereas we have some things here going out towards like negative 60 or probably plus 60, right? And so those would be like the very safe Republican or Democratic seats. And again, what the Republicans are trying to do is to limit the number of safe Democratic seats and increase the number of safe Republican seats. So we have a bit to do. Also, the jitter isn't totally working, right? You'll notice that they don't have any points overlapping on each other. Also, at the extremes of like negative 40 and plus 40, those values are all stacked evenly on top of each other at that limit line, okay? So there's a few things we need to do here, and we will take them on, but rest assured, we will get this to work. So let's start with, let's limit things to negative and positive 40, okay? And so I'll come in here, and within this mutate, I'll do difference. And so difference, I'll do a case when. So if difference is less than minus 40, then what? We'll make that 40, or sorry, minus 40. My fingers aren't working today. That's not good. Difference greater than 40, then we'll make that 40. Otherwise, we'll put in true. That then will be difference, okay? So the case when statement is kind of like a if-else statement where you have more than, say, 1 or 2 options, right? And so now when we include this in our pipeline, we see that we've now capped the limits at negative 40 and plus 40, okay? Great. Let's go ahead and think about the one, or the faceting, right? So we can do that down here with geom jitter, where we can do facet wrap, and we'll do, let's see, I'll do tilde, and then we'll do what? Districting. And we'll then do n row equals 2. And my y, instead of districting, I'll make that 1. And so now what we get is we get new and previous, right? And then we see that things are centered at 1 for both of these types of plots, okay? Thanks for joining us, Mohammed, from Egypt. That's awesome. And so Mike is saying you use position jitter within geom point rather than geom jitter. You can set a seed to make it consistent each time you run it. Yeah, that's definitely true. So if I run this, this would be a case where I might, if I can pull it up here, use the plot over here, right? So if I run this multiple times on the right, you'll notice those points are changing, right? And I think in geom jitter, you're mentioning that there's a position jitter, right? And I thought that there was a set seed within geom jitter too, but that might be wrong. Yeah, so you can certainly do what Mike is mentioning if you use like geom point, and then position equals position jitter. That gets you the same thing, right? And then I think, as he was saying, let me just double check position jitter. Is there an argument for the seed, right? You could then do like seed equals 1. And so now when I run this multiple times, I get the same thing, right? I'm wondering if I take that, let me comment that out. Let me do geom jitter and do seed equals 1. Yeah, it doesn't like that. So Mike, you're right. So we'll go ahead and do that. So thanks for that suggestion. And again, that allows us to peg the representation of the data. And now this is like my standard disclaimer, pick a seed. So in this case, you might pick a seed so that like the points don't overlap each other as much. Generally, I tell people to have a consistent seed that they always use. And it's not so, you don't want to pick a seed to give you the data representation you want, if that makes sense. And I always use 1976-06-20. That is my birth date. And so that's what I often use. And that actually doesn't look so bad. So we're gaining on this, right? Where we now have the top, is the new and the bottom is the previous. So that's the opposite of what it should be. We could fix that. Could fix that by giving them different names that are alphabetical, or we could go ahead and do perhaps the more elegant way, which would be to make a factor, right? And so I could say districting equals factor on districting. We can then do levels, and then we could say that first is going to be previous, and then new, and that didn't change it, so maybe I need to flip the order here. And that did it. That puts the new, oh, no. I'm confusing myself. I want the previous on top and the new on the bottom. Let me put this back. Yeah, I'm the one that I think needs the coffee this morning. So we have the previous on top and the new on the bottom. The previous is the same as current and new is proposed. Maybe it would have been easier if I'd have called this this current and this proposed. Whatever, we'll roll with it. So that looks pretty good, right? And we're gaining on it. So I think the big thing that we want to think about, or the new thing I think I have to add in this episode, is using something other than the jitter plot, right? And so this is called a beeswarm plot, and I don't know why it's called a beeswarm plot. Maybe because like it looks like a swarm of bees, whereas this is a bunch of random points. I don't know. So there's a few things we could do to get that. And so let me go ahead and comment out our geom point. Another geom that we could use that comes with ggplot is geom.plot. And this gets us a dot plot, right? Which isn't exactly the look we want, right? So if I do question mark geom.plot, I don't use dot plots very much at all. So I have to remind myself of how I want this to look. So I think what we want is the stack dir. And oh, so the up is the default, down, center, and then centered but with dots aligned. So let's go ahead in here and then do stack dir equals center. And so that gives us something that looks a lot like what we have up here, right? It looks more like this than what we had before. One of the things that is wrong with this, however, or a problem with this perhaps, is that it is binning the x-axis. It's taking the x-axis and creating bins. And you can kind of see that here with like bin width, so 1/30th of the range of data. So pick better values with bin width. And so if I did, if I do bin width equals, let's say 0.5, then the points get actually smaller and they're harder to see, right? And so I suspect we probably want to go to like, 1 divided by 38. That's the number of bins was what they suggested, right? So this would be like bin, what did they say they used up here? Bin width, the 1/30th of the range of data. So if we make this say like 1, and this should be bin width, then they're a little bit bigger than they had just been, but the points are small, right? And so again, ultimately, I don't think this is what we're going to want either. So let me go ahead and remove that. And there. And I'm not sure if, so this is 6, 10, 11, 13, 16, 19, 25, 29, 32, 38, right? So it shows all the data. And so this would be a way to do it. Again, it's putting things into a bin along the x-axis and then stacking things within the bin. It's a lot like a histogram, okay? Rents says the resulting beeswarm comes from the resulting swarming or bee-like effect that reveals the true frequency of data points within the defined ranges. And so the y-axis values aren't meaningful, right? Yeah. So this was like option number 2. And so what we're going to do now is add another library, which will be ggplot2. And so this will get us a geom for making a beeswarm plot. And so we can do geom beeswarm. And let's see what happens if we just throw that in. So nothing happens. It looks like that's like geom point without the jitter, right? And so in a little bit of my exploration of this, I saw a couple of parameters that are useful. So CEX is like an expansion factor. And so if you come down here to the help, scaling for adjusting point spacing, values between 1 and 3 tend to work best. 1 is the default, right? So if we throw in here CEX equals 3, then we see the points are bigger, but we don't see separation. What happens if we go up to, say, 6? So nothing is happening, actually. And so I'm not sure what that's about. So if I come back to the help, and let me think here. It doesn't seem to be jittering things on the Y direction. I wonder if it only wants to jitter things on the X direction, right? And so something that I will try here is to add chord flip. And so chord flip will flip the X and Y axes for us. And that also didn't do the jittering like I thought it would do. Oh no. If I put this down to 3. Okay, so I'm going to come back to the help, and I'm going to copy their code here. And so let's see, this first one shows you kind of what it's supposed to look like, right? It's complaining about ggplot because ggplot is an old thing. If we look at this, that's beeswarm. And so I wonder what happens if I flip value and variable. So that works. I wonder if it doesn't like me using a continuous variable on the y-axis. Because this, rnorm and runif are categorical, right? And so if instead of 1, I put districting, will that work? That works. Okay, then I think maybe we can get rid of the chord flip. Ah, that works. Cool. But now we have previous and new, right? Which isn't exactly what we want. We want only the previous with the previous and the new with the new. And so one thing I could do would be to come back and make this, say like 1 as a character. And so then that, we'll do that, right? The other thing that, again, is perhaps a bit more elegant would be within facet wrap to do like scales scale equals free underscore y. And so then that will remove any categorical variables that are not actually being represented in that facet, right? So like within previous, we no longer have, well, I'm not doing it in my, so this should be y equals districting. There we go. So we now have previous and new and new. And that scale equals free y removes those categories that aren't being used in that facet, right? So now what we can do is within beeswarm, we've got 3. If we go back to 1, the points get smaller, right? But if we take it up to say 5, then those points get bigger and we see that they don't overlap each other as much, right? And so let's go ahead and try to make the points larger. So we can do that with the size aesthetic. So let's do size equals 2. And so those are bigger. Let me put these next to each other, but they're not quite big enough. So let's go up to say 3. And those are good. I think those are about the right size. Maybe if we did like 3.5. Let's go back to 3. Okay, cool. So now we have that 3, that size, and we can increase the CEX so that our points don't overlap. And so you'll notice, in contrast to like, I guess we saw this with dot plot, right? Is that you know, at the limits here, those points stack up on top of each other on the same vertical grid line. So let's increase our CEX to say 6. Okay, we can go up higher to get more separation. And so that's looking good, although notice we're kind of losing some of the points up here. That's weird. Maybe we'll go up to 8. All right. So we get separation. Okay. I'm not sure if I trust that we're not losing these points on the edges. One thing we could do is do chord Cartesian. And we could do clip equals off. And so that then shows us that point there, right? I'm going to trust that we're not losing anything up above, but we'll see. So there's a couple things about this appearance that I don't totally like. So first of all, we've got kind of like these wings going off for the new, right? And we also don't have the points quite centered on 1, right? They're kind of funky. So let's look at the help for geom beeswarm. think I already had that pulled up over here. And so let's see. So mapping data stat method for arranging points. So see details below, side, priority, fast, dodge width, corral, those types of things. And so there's no details section. What am I supposed to do, people? So let's look at beeswarm swarm X. And I don't know if I see a method here either. So that's frustrating. Yeah. So I think what I will do is in here, I'll put method equals nothing. And hopefully it gives me an error. It gives me an error, and it tells me the different arguments that I can use, right? So I'm going to go ahead and copy these and plop them in here. And I'm going to try these out. So I think swarm was the default method. Yep. There's also a compact swarm. That looks decent. So maybe I'll put a star next to that. Hex. Yep. And so that doesn't, I don't like that. That's more like the geom.plot, right? What does square look like? That also looks a bit like geom.plot. What does center look like? So that centers it. It's still discretizing the axis pretty hard, I think. And what did we see for compact swarm? I think that's going to be more of what we want. Although now I'm worried about why things are being, why these points aren't centered on the horizontal grid line, which seems weird. There's a detail in the vignette PDF on GitHub. Thank you. Let me ggplot2 vignette. You said on GitHub. And then let's see. So there's quasi-random. We might try that out. Let's see. Could you choose the Y value for each dot by sampling without replacement from a list of possible values? Yeah, you could do that. One challenge with that, I think, would be that things wouldn't necessarily, I wouldn't trust things to be centered. That would be something to try. Maybe we can try the geom quasi-random. Let me just look through these real quick. Geom beeswarm. All right, I know this doesn't make for entertaining viewing, so thanks for being patient. These are the different methods down here that we've already looked at with geom beeswarm, right? All right. I wonder what happens if we do like priority. Let's try that. Let's see. So this is what we have. So if we do priority, and then it's got density. So that gets it centered, right? Cool. So I think that makes the density the priority. Whereas if we used random, then it's still, well, no, it doesn't quite center it. Like these four are off, right? So let's go ahead back to density. And I think that will look pretty good. We certainly have this weirdness where things are kind of going out into the y-axis too far. Maybe what we could do there is within chord Cartesian, we could do like y-lim. If we do like 0 to 1.5, I think that will work. Yeah, that works. So that then gives us a wider limit range. I think I've got too much on one side than the other. And maybe we need to increase the expansion here. So let's do 0.5. And now that's centered. I don't know. What happens if we go up to 10? Are we just going to have the same problem we had before? No, I think that's okay. Let's go up to 11. I don't know. I think we'll just get right back to where we were. Yeah. All right. So I'm going to... What? Let's take that back to 10. And I think this is, I'm going to call this good. I can't help myself. Those dots at the ends are annoying me. Okay, I'm going to take it back and get rid of that y-lim. Start over here. Okay, there we go. And I'm going to be, I think, willing to live with this being on the edge. We're going to deal with that here in a minute anyway. Okay, so let's roll with this. And let's go ahead now and focus on the color, because this is, like I said, for a relatively simple looking plot, this is getting a little bit challenging. And I think part of that is because we're trying to figure out how to use this geom beeswarm package, right? So let's take on the color. And so I think what I will do is I am going to do something a lot like what I did up here with this case when, where I'm going to create a column that I'll call color, which will use a case when. And when the difference is greater than 20, then it's going to be red, right? And when the difference is greater than 10, it's going to be light red, right? And then when the difference is greater than, well, I don't think we have anything greater than 0, right? If the difference is less than, or no, we do, sorry. I was looking at the bottom plot rather than the top plot. And then we'll do lighter red, right? And then when the difference is less than minus 10, then we'll do light blue. And I know these colors aren't right. I'm putting things in here just to initially show my logic. So less than minus 20, then that's going to be blue. Okay. So shouldn't we work with an absolute value of the difference? The original value starts at 40. Yes. So the limits, or the text on the axes, are all positive, right? But if I make all the values positive, then when I map the difference as a positive to the x-axis, everything will be on the right side, right? And so I'm kind of doing a trick here by keeping the minus 40, and if it's negative, thinking that's Harris, and if it's plus 40 or plus something, that's Trump. Okay, good question. And then what we can do is we can take color. We need a comma here. And we will then, instead of color equals winner, we'll do color equals color. And then what we'll do is scale. I'm going to say, we'll say color identity. And so that will use the color that is in the column, right? So if these are colors, then we'll get those colors, right? So I'm going to get my plot. I'm going to get my digital color meter, which I still haven't put into my doc for some reason. And let's go ahead and try to pick off the actual colors. So let's see. I think I am copying and pasting too quickly. Get that. And then for the light red, that's this. And then the lighter red is this. Like a pink, right? And then the blue will come over here. Plop that in. And then this darker blue here, okay? And so, again, if we run just that part, we now see that we have a column for the color that's got the hexadecimal code, right? And we've removed winner, and we are now mapping color to color, right? And so now what we've got is our colors, but we don't have the dark blue. So I did something wrong. Good. This allows me to illustrate something about case when. So case when works in order, right? So if I had a value of -40, that's not greater than 20. So it comes to the next line. -40 is not greater than 10, comes to the next line. -40 is not greater than 0. -40 is less than -10. Therefore, then we get the light blue, right? So it never gets down here. So what I could do is I could flip the sign, or I could flip the order of the lines, right? So now -40 is not greater than -10. -40 is not greater than -20, but I could make this -40 and I could make that -20, right? And so it is complaining, because it is greater, rather than greater than or equal to. So there we go. Now we have our points, and they are colored by kind of the percent margin, right? But one thing you'll notice if you look closely is that the two circles that are between 0 and +10 have a black edge on them. And also, if you look closely at these down here, these red points that are greater than 10, they actually have a white border around them. And so this allows me to use my favorite plotting symbol. Do you have a favorite plotting symbol? Let me know in the comments. Then I could say shape equals 21. And that allows me to set the fill color separate from the border color, right? So here now, I need to say fill equals color. Maybe I'll call that fill equals fill. And then we'll do scale fill identity. And then back up here, instead of color, I'll call that fill. And so we don't see any difference, except now we have a black edge to all of those points, right? But we only want the black edge on these 2 points, right? So what we can do is I'll come up here and do the same type of thing. So we'll do color equals case when, and I'll say absolute difference is less than or equal to 10. Then it's going to be black. I could really just do this with an if else. That's probably easier. If else, if the absolute value of the difference, and I'm missing a parenthesis here. So if it's less than or equal to 10, then I want the border to be black. Otherwise, I want it to be white. Okay. And yeah, I think that works. And then down here in ggplot, I can do color equals color. So the fill determines the side, the interior color of symbol 21. The color is the border, okay? And so now what we need to do is we also need to do scale color identity. And so now what we see is that we've got black circles on those two, and everything else has a red circle. Cool, right? And maybe we can make those symbols a little bit bigger. Let's go up to 3.5. And those look, I think, pretty good. Nice. Great. So Malzi writes in to say, new to all the R stuff and enjoys watching, helping learn the thinking process. So that's why we do this. So thank you. So Mark, you said -10 greater than difference greater than -20. You can't write it out like that, but you could do like difference less than -10 and difference greater than -20. That you'd have to use that Boolean and to do that kind of compound expression. But good thinking. All right, so let me clean up my code a little bit here because I'm getting a little bit lost in things. I'm going to leave these two statements in here. So those of you that have joined late, don't worry if you joined late. I do post all of the code that I'm developing to a website. And so at the end of the episode, you should be able to go down below in the description to get a link to that blog post where you can get all the code. And you can play around with the code to see if you like what I did or not, okay? So the next thing we're going to do is let's start making this look nice, right? And I have some thoughts on how to do that, but we'll have to see how this goes. So let's start by what? Let's clean up our titles. And so maybe I'm going to substitute previous and new with current district and proposed district. And so let's go ahead. And so I did that in here with levels equals previous and new. And so what I can do would be like labels equals current districts, and this is going to be proposed districts, right? So now when I run this gets me current districts, proposed districts, right? I'm going to want those to be bolded, right? And so, yeah, we'll go ahead and jump into the theme function now. And the theme function allows us to modify the appearance of things that aren't directly connected to the data, right? So we can do strip.text, and that's what the header on each of those facets is called. We'll do element text, and I'll do face equals bold, and we'll do hjust equals 0 to get that to be left justified. And so there we go. We have current districts, proposed districts. I can get rid of the gray background by doing strip.background. And I can then do element blank. And that then gets rid of that background. And we see that we have our point back, which is a win. Cool. And let's go ahead and also get rid of the current districts, proposed districts, and these titles on the axes. And we can do that with axis.title equals element blank, axis.text.y equals element blank. And so that then gets rid of those extra titles and really expands a lot out for us. It got rid of my legend. Why did it get rid of my legend? I think it got rid of my legend when I went to this kind of continuous color scheme, right? Okay. So we want to get rid of that tick and also the ticks on the x-axis. So we can do that with axis.ticks equals element blank. So I always have to enunciate ticks as being different from text because I don't know, with my own Midwestern accent, I'm sure the two might sound a lot alike. Okay, cool. This is looking good. let's go ahead and get rid of, I'm going to turn off the grid lines and then we'll turn it back on. So we'll come in here and we'll do panel.grid.major equals element blank. And maybe I'll do major.x. And then we'll do panel.grid.minor equals element blank. And so that will turn off the minor grid lines on the x and y axis. So now we see that we no longer have those. And I think I meant the major y. Right. I want the y grid line, the horizontal one, to go away. I often get those confused. So there we go. We now have those vertical grid lines in. And so you'll notice that they have vertical grid lines, but they're dashed. So let's go ahead and then do panel.grid.major.x element line. And we'll do color equals gray. And we'll do line width equals, well, let's say 0.3. And then we'll do line type equals dashed. And let's see, why is this? Okay, I don't know why. And so now we can see we've got those dashed gray lines in the background. Facet wrap has taken away the X tick marks on the top plot. Yes, good eye. As you'll notice, in their version, they have the same information on the bottom of the top panel as they do on the bottom panel, right? So we need to get that back. So let's do that now. And in facet wrap, there is an argument, I think, called axes. I think I can say both. No. So it's either all X, all Y, or all, not both. So let's make that, I think, all X. There we go. We now get the same information for the top panel as we get for the bottom panel. And so in full disclosure, if I were making this plot, I probably wouldn't duplicate the x-axis text. I think that's just kind of redundant, but hey, we're trying to recreate their plot, not my plot, okay? So good question mark, good eye. Let's go ahead and turn the background to be white. And so we can do panel.background element blank. And so that basically takes away the background from the panel, although the outer frame is called the plot. And so if we get rid of the panel, then we'll get the color of the plot. Okay, and so now we have that nice white background. And let's see, they also have this gray rectangle in the middle between 10 and 10. Actually, this reminds me, they actually have grid lines every 10 units. So let's go ahead and do that. So to do that, we're going to need to do scale x continuous, and we'll do breaks. I'll do seek from -40 to 40 by 10. And so now this gives us grid lines every 10, right? But I think it was Rents that asked about using the absolute value. And that is to fix the markings, the text on the x-axis. The other thing that they have is the +40 or greater, +40 or greater. Those are left and right justified. And then at 10, they have Harris and Trump. So to add that information, we'll come back in here and we'll do labels, and we'll then make that a vector. And so we'll then do +40 \n for a line break or greater. And then it's going to be +30. My fingers are, I don't know, they're not quite awake yet. 20 +10, that needs quotes, but I think that +10 has a Harris under it. So we'll do \n Harris, and then 0. And let's come down here with that 0, and then we'll do +10 \n Trump, plus 20 plus 30, and then plus 40 backslash n or greater. Okay. And go ahead and put that on another line. Okay. So now we should get the text we want on those x-axis breakpoints. And sure enough, we now have the plus 40 or greater on either end. And to Rentz's comment, we have the positive signs on the left side of the plot. One thing that might annoy you, because it sticks out to me, is that the plus 40 or greater are center justified, whereas these, the plus 10 Harris and Trump and everything else, is center justified, right? And so one thing that I wonder about is that there is an argument for HJust. And what happens if we do 0 for left justify and then 0.5 for everything else? And so there's going to be 1, 2, 3, 4, 5, 9. So I'll repeat this. So it's maybe too many, and I think it's 0, right? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So left justified is 0, center justified is 0.5, right justified is 1. Something makes me feel this isn't going to work, but hey, we'll try. Did not work. Negative 40. So let's see. Aquilino, shouldn't it be minus 40, minus 30, minus 10 on the left? So it is. So if you look at the breaks here, it does have those minus 40, minus 30, minus 20, minus 10. But then I'm assigning to those breaks these labels. Okay. If I come back, it is unused argument. It doesn't even like using HJust. Oh, that's why. Because this should be set in theme, not in scale x continuous. So let's come down here, and then that's going to be axis text dot x equals element text. Throw that in. Get a comma at the end. Yeah. Do we miss data points in the new district facet? Look at the red dots at plus 30. Oh, well, I've totally screwed things up. Let's see. Did I forget? Hold on a sec. Let me get back here. Huh. So we have 1 point there and not 2 points. It's possible. So let me count. So we got 3, 6, 8, 11, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 1, 2, 3, 4, 5, 6. I'm not sure what happened. I wonder if somehow one of our points is in this pool. Like I noticed that 1, 2, 3, 5, 6, 7, 8, because they've got their 8 there. I'm not sure if that just disappeared. If I come back here, kind of, I badmouth this plotting panel, and now I'm going to go back through everything. So I think what Rentz is noticing is that on their version, there should be like 2 plots right in here. But I don't think we ever had that second point. So I think that there's maybe a subtle difference in the data that we're using. And I'm not really going to worry about that just because this video is already going a little bit long. So Mark said you could put in a seek of 0.5. So it wouldn't be the seek function. It would be, let's see. So like that's what I've got, right? So what I could do would be like C0 and then rep 0.57 times and then 1, right? And so that would get me the same thing. But I am going, so I'll go ahead and replace that here. That's a good idea and good way to keep things dry and simple. And instead of element text, I wonder if element markdown vectorizes the HJust, okay? And so element markdown comes from one of my favorite packages, which is ggtext. And let's see. Well, I forgot that element markdown doesn't like \n because it is using HTML. So instead of the \n, we'll use the br anchor from HTML for a line break. And so we'll put those in here. And maybe I'll go ahead and put these all across just to kind of make things not slide across the side of the screen so much. And I'm building the anticipation, I know, to see if this will work. It worked, right? We got right justification, left justification on the left side, right justification on the right side. Awesome, right? Cool. One other thing that I can do while I'm thinking about it is add in the Libre Franklin font. So we'll do library show text. And then I'm going to use the Libre Franklin from Google Fonts. So we'll do font, add Google, Libre Franklin, and I'll call that Franklin. And then we'll do show text opts DPI equals 300, show text auto to get it all loaded. Okay, so now we have that Libre Franklin font. And now what I can do back up here with theme would be to do text equals element text family equals Franklin. And so that then gives me the Franklin font. I mean, it's pretty close to what the New York Times uses. It's not exact, but it's pretty close. And I think their font is a little bit smaller than mine. So again, here, we'll go ahead and do size equals 8. I think that shrunk it a little bit. Maybe we could go down to, say, 7.5. And I think that is a good size. Cool. I think the strip titles could be a little bit larger. And so again, that was strip text. And then we'll do size equals 9. Maybe bigger still. We'll do 10. I think that's good. Great. Okay. Now, access label or access text? Not sure. I'm not sure what that's referring to, but let's go ahead and put in this gray panel between the -10 and the +10. I think that's to indicate that those are districts that could end up going either way in the next election, right? Those are kind of like the not safe seats. So to add that, I am going to add a annotation. So we'll do annotate. We'll do geom equals rect. And I'm going to run this before geom beeswarm because I want the panel to be behind behind the points, right? And so there's an xmin, an xmax, and then a ymin and a ymax. And so our xmin is going to be -10, and our xmax is going to be 10. And then our ymin, I think, is going to be 0.5, and our ymax is going to be 1.5. And then we'll add that in. And I've gotten a hit in here. There we go. And so, yeah, so I think I've got the wrong y limits. So I think I changed that in Cartesian? No. Okay, let's take that up to say So I also have the expand on the y-axis. So let me turn off the expand on the y-axis. So that would be like scale y discrete, and we'll then do expand equals c0, 0. Actually, you know what? I'm going to add that to chord Cartesian. I'll do expand equals false. And so that kind of threw things off to the left a bit. But that didn't fix my y-axis problem. So I need to change those y-min, y-max. So let's do 0.25 to 1.75. And that works better. And I'm noticing that resulted in some more overlap of my points. Maybe I'll take it to say like 0.4 to 1.6. And what? Let's see. Can you get the plot limit, like get y max, get y min? I don't think so. I have an idea. If I do NA on both of these, I wonder if it'll get it for me. Normally when you set the limits on an axis, you can use NA to have it pick it for us. And nope, it just went away. So let's see, let's do 1.7 and 0.3. And I think that's pretty good. I'm gonna hold off on futzing more with the CEX and the size of those points. I do need to change that gray color. It's a light gray. And so back up here in geomrect, I'll do fill equals like gray 80. And so that's light. We could probably go even lighter. Let's do gray 90. Nope, I opened the file too quickly. There we go. Okay, that's good. But we need that vertical gray line at 0, right? So we'll add that after the rectangle, but before the points, right? So we'll do geom v-line, and we'll do x-intercept equals 0, and we'll do color equals gray. Let's see what this looks like. Cool. I think I want to make it the same thickness that I had for my grid lines, right? Which was 0.3. So we'll do line width 0.3. Cool. All right. So this is looking good. One thing I'm noticing about the titles is that once I turned off that expansion, it moved the position of like the P and that grid line is now off. I kind of want the P to be the left of that. So one thing I could do within chord Cartesian would be like limits, I guess xlim. Let's say C negative 41 to 41. And so that brings things in a bit. But I could also remove the margin on the strip. So strip text here, right? I could then do like margin equals margin, L equals 0. So that moved it over left, but then we lost some of the margin below the text. And so we'll want to add that anyway to put in those extra labels, I think. So we'll go ahead then and do B equals 10. Okay, that adds that. Let's increase that even more. Let's try like 30. So that brings that down. Okay. Maybe I'll go a little bit more. And let's go up to 50. And so what I want to do then is put in this text in between, and that's probably too far now. So let's do 40. Okay, cool. And yeah, all right. So now what we want to do is add these titles in here, right? And I'm going to do that now using geom rich text, right? Because I have a mixture of bold font and regular font, right? And so I'm going to make a new data frame that will go with this. And I'll call this text annotation. And then this will be a tribble. And so we're going to have an X position. So it needs to be like a tilde, right? Tilde X. And then we're going to have the color. And we're going to then have the HJust. And then we're going to have what? The panel, right? And so then that is going to be, what did I call that? Districting, right? And so we need the districting because we're going to put different text annotation on each of the two panels, right? So X is going to be, I'll say -41. And then our color, I'm going to use the same dark blue that we have up here. And then the HJust will be 0. And then the districting will be what? I think we want current districts. And then we also want the label, right? And now we're going to go ahead and grab this. I'll plop that in. And again, we want the line break HTML anchor. And then this 11 districts, we can use 2 stars, which is markdown for bold. Okay, and so now we're going to do 0. And then our color is going to be black. Our HJust will be 0.5. Again, that's going to be current districts. And then our title is going to be 2 districts within a 10-point margin. And those 2 districts need to be bolded. And then our third is I'm going to put at 41. And then we're going to want that strong red color, which is right here. Plop that in. I need the # for hexadecimal. And then we want 1 for it to be right justified. And we're going to do current districts. All right. I'm feeling good about this. And then the 25 districts, again, that's going to be bolded. And then that. So I haven't done the proposed districts yet, but let's see if this works. Oh, it's upset with me. Oh, because this should be tribble, not tibble. Still not happy with me because I forgot a comma up here with label. There we go. And so now we have text annotation, and we can then add that to our ggplot where, let's see, let's go ahead and put that maybe after the geom vline. So that's going to be a geom rich text. And again, that comes to us from ggtext. Our data is going to be text annotation. Our AES, X is going to be X, Y is going to be something, and then label is going to be label, color is going to be color, HJust is going to be HJust. And I'm missing a closing parentheses there. So then the Y position needs to be figured out, right? So I think our limits that I set with the rectangle went up to 1.7. So what happens if I make this like 1.9? Let's give that a shot and see. It's going to complain because I don't have data for fill in geom rich text or in text annotation. And so what I can do is inherit AES equals false. And so what that means is that geom rich text isn't going to be using this AES statement. It's not going to be inheriting that. I've defined all my own things down here, right? All right. Discrete values applied to continuous scale. So it's worried about my factors. So I think I need to make this a factor, which I can do. So I can do mutate label or districting equals factor on districting. It's still not happy. Let's see. Current districts, current districts, current districts. I'm gonna go ahead and copy that up here. Make that levels. I've got too many things going on here. All right. Levels must be size 3 or 1, not 2. Let's see. So Ren says, shouldn't we have 2 colors, or is it just a bold versus not bold effect? Yeah, it's bold versus not bold. And the bold we're getting with the markdown of the 2 stars. Scale Y discrete for the text. I don't think so. Because I think the scale, we're not putting things on the y-axis, or I'm going to copy this down, and then this is going to be wrong, but I'm going to put in proposed here. So the X, the color, the justification, the districting will be right, but the label will be wrong. Let's see if this works. And I forgot a comma here. Oh, levels must be 6 or 1, not 2. Oh, duh. Because I forgot to put it within the factor function. All right. I'm sure somebody saw that out there. The parenthesis. There we go. Now it's not complaining. Discrete values supplied to a continuous scale. Let me just check something here real quick. If I turn this off, that works. If I leave that in, discrete values applied to a continuous scale. And if I look at last trace, this doesn't really tell me anything. I wonder if it is because my y-axis is discrete, right? So like I use like y equals districting, which is discrete. Can I do as numeric on that? Oh, bother. Yeah, it's not happy with that. Let's see. So I'm a little stumped here. I think my y-axis position in geom-rich text needs to be a character. So if I change that to A, that works. Huh. But how do I make it? How do I move that up? I don't know. Put this rich text last. Interesting. Let's try that. Put that after the geom beeswarm. So that's there. But if I make this one, good job, Mark. You're awesome. You saved me. All right. So I think it, because I've had the geom rich text, where did I have it before? I had it, yeah, I don't know. The order shouldn't matter, but clearly it does. So if I put this then to 2, now that's moved that up, and that looks pretty good. I don't want the border, and I don't need this gap between my title and that. Thank you very much, Mark, for suggesting that. I was worried that I was going to have like my first episode where I couldn't deliver on the promise to recreate the plot. So thank you. I think we're going to be able to do this. So to get rid of that border, we can do label dot size equals 0. So that gets rid of that label, right? Nice. I think the line height is too high. So let's do that. Again, that's in geom rich text. We can do line height, or I think it's one word, equals 1. That pulls that together. I think the font is too big. Oh, I need to fix the labels. All right, let me fix the labels real quick. I was so excited at Mark's suggestion that I forgot to do what I was supposed to do. Okay, so we'll bring this in. All right, so 8 districts, the BR, get that with 2 stars, 0 districts, and that's bolded, and then, yeah. Yeah, so after the 2 districts, there's the BR. And then down here, 30 districts. And that's going to have the bolding, the BR there. Running all this. Cool. And like I said, we can shrink the font down a little bit. So let's see. Right, the size in geom rich text, we'll do size equals 2. So geom rich text doesn't have the size.unit argument that I like to use to express things in point size. So it's a bit of a trial and error here. So let's take this up to say 4. Let's try 6. Oh, that's too big. Maybe it was 4. Okay, let's take it down to say 3.5. And that's pretty good. Is that an O? It looks like an O instead of a 0 for the 0 districts. It is an O, but I copied it. So let's try that now. Okay, that looks better. And that's the right font size. And so like we said, we can get rid of this margin below the proposed districts. And so that was in the strip, right? So I had that B equals 40. So let's go ahead and remove that. So we need something there, I think. So let's maybe do bottom equals 10. Okay, we can go a little bit further. Let's try 20. Okay, maybe like 15. All right, let's do 18. Cut the difference. Cool. All right. But one thing I am noticing is that on theirs, right, the 8 districts is left justified with the title of the facet, and the right is right justified with like the right edge of the plot. And I think I actually, so there's a padding argument and there's a margin argument in rich text, right? So maybe this is what you were saying, Mark. Label padding equals margin 0 all the way across. And then let's do label.margin equals the same thing. And so that then gets that left justified right under that. And yeah, so it looks like the V line at 0 is too long. Yeah, it goes beyond the gray area. So I think our scale, so I don't know how to set the limit on a discrete axis. Because this seems to be going up into the middle, which makes me think that these labels are center justified. So maybe if I make them upper justified, then that will put that at the bottom. I don't know if that what I just said makes sense, but we'll give that a shot. So we'll do vjust equals 0. Ah, that did work. Maybe. But let's move them down now, right? So it's upper justified. And so let's see. Let's try 1.7, which would be at the top, right? Bingo. I think that's pretty decent. Maybe for those, we could put a margin below them, right? And so that would be like the margin. So that would be, this is top, right, bottom. So let's do 10. Okay. Maybe too much. Let's go 5. Okay. And so then we need to, I think, add more margin into the strip title. And so let's go up to 25. Good. Maybe a little bit more. 30. Better. And I think I will go to 33 and probably call it there. Nice. Okay. Coming together. Now what we could do is add a space between proposed districts and the bottom of the upper panel, right? And so in here, we can do panel.spacing.y. We can do unit. Let's do 10 points. And so that adds a bit of space. Let's go up to say 30. Add some more space. And I don't know, maybe go down to like 25. And I think that's pretty good. So one thing I just don't really like, or I feel bad about, I guess, between my version and their version is the overlap of these points. And if I were to increase the CEX, I don't want to belabor this point because we're already approaching 2 hours here, and I'm sorry for that. If I take this up to say like 9, then we start bleeding over into this other stuff, right? And changing our dimensions and everything, which I'm not a fan of. So let's take that back. And if we made the size 3, that kind of shrinks the size of the points. But we still have that problem where these points fall on top of each other, which isn't so ideal. But, you know, I think I'll take it back to 3.5. And like I said, we're already at about 2 hours. So I think I'm going to call it here and live with the frustration that I don't have 100% reproduction of what they did. And I think like the most important difference between what they did and what I did is that, let me get the full screen here. Theirs on the left, mine on the right. Let's kind of blow that up, put this next to it. That the main difference that I think is most significant is the overlap of the points, right? That there's a couple cases here where the points overlap. And I'm going to chalk this up to just my lack of familiarity with the ggplot2 tool. And I'm sure there are perhaps other methods in there that would allow us to not have the overlap like we have here or at the ends. And yeah, so I think this was a fun challenge. Like I said, deceptively simple plot to recreate. And let me kind of quickly go over here with you a few of the things that I thought were fun to think about. So first of all, getting the data, scraping the data from Wikipedia using rvest, excuse me, getting data out of data wrapper. I'll have to definitely check out that data wrapper R package. Playing around with different ways of jittering the data. So geom jitter we saw, or using geom point with position equals position jitter. We talked about dot plot. We talked about beeswarm plots, right? And then changing the color according to the margin, changing the fill according to the margin, changing the color according to the different margin, right? To get the border on that plotting symbol. Those grid lines, the gray centerpiece, using element markdown to get left and right justified on the ends of those labels was pretty slick. Modifying the titles of the two facets, as well as then putting in these different annotations to basically 3 different regions of the 2 panels, right? So this was a lot of fun. Sorry for going so long here today. I really enjoyed doing this with you and your all's feedback and comments along the way. Yeah, so if you give this a shot, see if you can't figure out how to get those points to not overlap. I would love to see a comment down below in the comments to this video. Like I said, I'll put the code as I have it currently into a blog post. I have to go work on a grant proposal that I'm horribly far behind on. Otherwise, I would probably spend the rest of the day trying to figure it out myself. Anyway, I will leave that to you as homework. Thanks again for tuning in to this live stream. Like I said, really appreciate your all's comments and time you've all spent watching this with me. Please tell your friends about what we're doing here on Code Club. I've really enjoyed these live streams and the interactions with you all. And I'll see you next week for another episode of Code Club.